In this video, I'm going to show you how you can use some incomplete block design, a macro that I wrote in SAS to use to evaluate different incomplete block designs. So this code only works when um, you have just an arbitrary set of treatments that are just categorical, like treatments 1, 2, up to T. It doesn't quite work when you have a factorial structure. That's not what this is really built for. So the first thing that you need to do is you need to open up the ibd.sas program and just run the code. So you can do that by highlighting the whole thing, but you can also just say run when you do it. So if you go to the log, it just runs the code, and it's basically creating a custom program. For those of you that kind of know something about SAS programming, I'm using proc IML interactive matrix language to do some matrix calculations and eigenvalue calculations to calculate things like the information matrix right here, eigenvalues, and then this is going to be the treatment by block incidence matrix, and this is going to be the concurrence matrix right here. And so it just calculates a lot of design properties of interest. So this kvec, this is going to be looking at the block sizes, so it's a vector over the k parameters. rvec, this is looking at the different replications across the different treatments. This will look to see if your design is proper and if it's binary, and those are things that we just kind of check for. And so this looks to see, it actually tells you if you have a balanced incomplete block design by looking at the treatment concurrence matrix, or not, yeah, the treatment concurrence matrix right here, and it should be constant along the diagonal and then constant on the off diagonal. That's what it's checking for right here. It also calculates the E, A, and D criterion as well. So if you have two designs that you want to compare, you'd want to run this program for those two block designs and find the one that minimizes either the E, A, or the D. So once you have this macro run, you need to input a data set. And it has to have this structure. So you can call the data set whatever you want. I just call it usually block des for block design. But you have to have, you don't have to have, but you have to have a variable for your blocking factor and your treatment factor. So I usually just call it block and treatment, and this is what it's called by default in the SAS program. So you need to input this design yourself manually. And so in the first column, here I have my blocks, so block 1, block 2, block 3, 4, 5, 6, and 7. So this is that 7 blocks, 7 treatments, block size 3 example again. And these are my treatments, 1, 2, 4, 2, 3, 5. Now it's absolutely crucial that your treatments are labeled 1 to T. And I know we've been doing, for at least cyclic designs, 0 to T minus 1. So you have to convert it to 1 to T by adding 1 to all the elements. And the reason is because of how the calculations are done in that macro. So once you've run the macro and you filled out your block design data file, you just highlight this, and then I'm going to click run. And so now this design exists in my work library. I also have a new folder for all my SAS macros, the IBD macro that I just wrote. And this is how you invoke the IBD macro. So you do a %, IBD, and then you tell the macro what data set you're referring to, what your blocking variable is called. In this case, my blocking variable is called block, and what your treatment variable is called. In my case, it's the same thing, treatment. So if you highlight this and click run, it gives you this output. And so it says, is it proper? Yes. Is it binary? Yes. Is it a balanced incomplete block design? Yes. And we can verify that it's a balanced incomplete block design by looking at the treatment concurrence matrix. Again, we want this to be constant on the diagonal and then constant on the off diagonal, so it's always 1. This is going to show you the T minus 1 eigenvalues. So notice that when this is a balanced incomplete block design, all of my eigenvalues are exactly equal to each other. And here are my E, A, and D values. So in this example, these are the smallest value. This is the smallest that D, A, and E can take because these designs are universally optimal with respect to all these types of criteria. So we can look at another example in this case. Here I have, again, 7 treatments, 7 blocks of size 3. But notice now I have a non-binary design where I've done treatment 1 twice here. So this is going to be an inferior design than the one I just showed you. So let's call this block design 2, and let me highlight this and run it. And then invoke my IBD macro for the new data set. So now it says block dis 2. I'm going to click run. And so this is what the treatment concurrence matrix looks like now. So notice we don't actually have 6 replicates of treatment 1, but it's overcounting because the design is not binary. It's also not a balanced incomplete block design. And you will notice that all of these values are larger than the values of the original design, which we knew were as small as it could possibly get. So this makes sense. So you can use this for any block design as long as the block design just has a set of T treatments and some blocks, and you input it in this way. So again, treatments have to be numbered 1 to T and can't have any other structure because of the way that the program calculates the matrix. And this is how your blocks have to be set up. They also have to be numbered 1 to B, however many blocks you have.